Okay, hi. So I'm here for 90 minutes. I'm going to talk about cinematics in Unreal Engine 4. We're going to build what you see here, more or less. I have things prepared, of course, but I'm more or less going to try to build this from scratch. And what we have is essentially two robots from Robo Recall. They're going to fight each other. It's going to be very cheesy and in a way like comedy, but it's going to be fun to watch. The overall goal of this presentation is to talk you through how the Unreal Engine works, how the pipeline works, how the workflow works, how all the tools come together and eventually lead to something like this. Okay? Who of you has experience with Unreal? Is there anyone who's been using Unreal a lot and you feel well experienced? No one? Anyone who has never used Unreal before? Okay, so all of you have used Unreal a little bit. Is that a correct assumption? Yeah? Okay, good. So first of all, my name is Sjoerd De Jong. I am Evangelist for the Unreal Engine in Europe. I travel through Europe. I go to conferences like this. I go to educations, universities. I visit companies and so on and so on. So anything to do with Unreal. I have a long technical background, so I started with Unreal Engine 1 in 1999. Unreal Engine 1 itself started in 1995. So both I and the Unreal Engine have been around for a while. I started as level designer. Nowadays I do more tech art. We released Unreal Engine 4 in 2014, public release, and we're now almost 4 years later. Just rough breakdown. Before I get to actually building something, I'm going to very quickly talk through a couple of general points about Unreal. Just things that I think are important. What I like about Unreal is it has all the tools there. Unlike certain other engines where they are very plug-in focused, and that has pros too. There are good things about that too. But I like the approach we take with all the tools are there. The tools are built by us. In fact, the next slide as well. The material editor, for example, we have the particle editor, we have Blueprint, we have all those different things. They're done by the same team, they're documented, they work on every platform, all the tools work together. For me, it's a major plus. And you can get really, really far with a very small team in Unreal. All platforms are supported. Pretty straightforward slide. Source code is available, in case you weren't aware, on GitHub. So you can modify whatever you want in the engine. If you make changes, you can push those changes back to us and ask us to incorporate them into the standard engine. So for example, you could make the editor purple, because you even have the editor source code. You can make the whole thing purple, and you can then send it back to us and ask us to fix it or include it, and we're probably not going to do that. But on a more useful level, if there is an issue in the engine, or there is a bug, or there is something wrong, right? There is something that prevents you from releasing your game, and there's always going to be something. And you can tell us, and we're going to fix it, but maybe we don't fix it fast enough, or maybe you want to have it fixed in a slightly different way. You can do that. You have the whole source code there. And that's a big plus. It's entirely free to use for education. There is no license management at all, by the way, so you can literally just copy-paste the files between computers. That also goes between team members, so it's completely open and flexible. And the pricing is essentially for games, there is a 5% royalty rate on the income generated by the game. That's more or less it, especially for smaller games. It's free for non-game usage. We do have support offerings on top of that, but essentially if you're, for example, an architect and you make an architectural visualization, it's free for those kind of things. And we give away money too, because why not? So we have the dev grants. It's a $5 million fund that we give away to anything that's cool in Unreal. Could be games, could be other things, could be education. You can apply. Typically, a grant is around 15,000, 20,000 euros, dollars. And again, you can apply. There's no end date. It's just an ongoing process. And in fact, we're working more and more with different publishers, with different funding partners, and so on, in order to really make it easier for indie developers to A, find a publisher or a good partner to work with, and B, to get access to funding. For example, we have the Xola fund, and you're able to apply to that and receive some funding to develop your game through that. Good. I'm going to switch to windowed mode. I'm going to forget about my slides very soon. I'm really bad with slides, so I'm going to switch to the editor and forget about my slides. But essentially, this is what we want to do. We want to build up the world geometry. We want to then focus on foliage and texture painting. Then we want to move into sequencer, talk about camera control. We want to talk about shots, takes, and sub-sequences, animations, and the blending of the animations. Eventually, we will talk a little bit more about some special things, special effects like post-processing with custom depth. We're probably going to record the physics. So we're going to have a couple of cars, they explode, so if cars fly away, we're going to record that into a sequencer. And then there's some additional stuff there towards the end. Towards the end, I'm probably going to start running out of time a little bit. There might be some requests from you or questions. So the last couple of points, especially video rendering and chroma keying, I'm probably just going to talk about that, show you how I've done it in the past, but not build it live. Everything else I do live. Cool? Good. Okay. And also, since it's a fairly long talk, if you have any questions while I talk, please just raise your hand. We can just take it during the workshop, because it's 90 minutes, otherwise you probably forget by the time we get to the end. Okay? Good. Okay. So I've got my project here. It's an empty level though, so I'm going to start building the level. I'm going to start off by actually building the environment rather than the cutscene. So we're going to start with rather straightforward work there. I'm going to just bring in the floor. So here's a static mesh. It's just a model. Just a model. It's a model of a giant plane. It's actually a cube. Very, very thin cube, as you can see. We just dragged it in. So we now have it in the world. Then sorry, I changed this earlier. Then I'm going to reset the location, so it's on 0, 0, 0. I just need to do that because I have content prepared and it expects to be on the exact same location every time. So there, then I'm going to do the same with the sidewalk. There, drag it in, place that. Then building, this is going to go nice and fast. Building piece, distant meshes. And now I have this already. Obviously, I have it a little bit prepared, but what I have here, these two are regular meshes, regular models that were just imported from somewhere, from a 3D package. But these two are blueprints. I'm not going to talk much about Blueprint today, but Blueprint is extremely cool in Unreal, I think. It's the visual scripting tool in Unreal. You can see this is where you would do the visual scripting. Now, in this case, I'm kind of abusing that tool for something it's not entirely meant for. I'm using the components in the viewport to essentially create a little prefab with all the different building pieces grouped together. Again, it's not really what it's meant for, but it does work. This may be more what Unity's workflow is like, but that's what I'm doing here. So I have all the different building pieces. Those are the distant buildings. And from this point on, I could continue. And I can just take different models, drag the models in, place the models. It's going to take ages to do. So we're going to use Notepad. We just open a text file, Control-A, Control-C, Control-V. I have stuff. Cool. Okay. Anything in Unreal translates to text. So whatever you take and you copy-paste to Notepad will become text. So because of that, it's quite easy to just, you can be in a chat program together, different team members, and copy-paste stuff to each other. Or in this case, I just save the text file for the sake of being able to easily put this together in a presentation. Now, it turned out that wasn't enough, so I did a few more text files until I had everything. So here's the rest. Cool. Level. Good. Again, they're all just different models. I could have placed these by hand. It's going to take me a long time to do all of that. So that's just it. You can see all of the things are different models. Okay. The next issue is that the floor here is perhaps not entirely realistic in texturing. It's the default material. So we're going to make something more appropriate for that. I've got a material here that I prepared, but it's not finished. So you can see I can assign that, just drag it on top of the model. The model receives that material. And what we're doing here is we have this mossy, grassy texture, and it's blending with a bunch of a leafy texture. And it's blending with a certain pattern. It does style quite aggressively, but we won't notice that once the trees are placed on top. In fact, if I open this up, it looks like this. So here's the material editor. We've had the material editor since around 2006-ish. And while it might look straightforward on the surface, it has a lot of hidden tools built in. That's the thing. Because we've had a lot of these tools already since 2006, 2007, 2008, whatever, we've had a lot of time to redefine these and really add in the small, subtle detail, the small, the daily workflow improvements. So there's a lot of things built in, material functions, material instances, material layers, material parameter collections, and so on and so on. Point being, this goes quite a lot deeper than the obvious you're seeing right here. But either way, you can see here's the two textures, and they're blending using this cloud texture. So that's how we're getting the pattern of the two switching back and forth. But it's not good enough. What I want to do is I want to be able to paint some dirt in it, some kind of road in it. so I can paint the path in it. Normally, it would use the landscape editor for this. So there's a built-in landscape editor. In fact, because we have time today, slightly longer time than I usually have, which I'll very quickly show you. See, landscape tools, built-in landscape editor. If I would press create, it would actually create it, you know, and it would be what you can expect, right? You paint the height map, you can paint hills, you can paint roads and all that. But we don't want to use the landscape in this case, just for the sake of doing it differently. I want to actually paint on the material itself. So I made this texture, which took me hours to make because it's a white texture. So I made a white texture. Okay. I'm going to import that in Unreal. Let's just put this somewhere. I can do it here. I'm just going to import that in Unreal, and it's that one. That imported. It's this one over here. So it's all nice and easy to add content to Unreal. You can see then I just drag it into the material. Now I have it in the material. Again, all goes nice and easy. And then I'm going to need the dirt texture I want to use. So I'm pressing the magnify glass that selects it in the content browser here. And I'm particularly interested in that texture and the accompanying normal map. So both of those. You can see that's the dirt texture, or gravel rather. And that's a normal map that belongs to it. I'll place a normal map there for a second. I'm going to move that up a bit. Move that up. This goes there. This takes the same UV projection as the other ones. So just the same connection. And then I add another lerp, linear interpolate. So I blend between A and B based on C, based on the alpha. The alpha is going to be the white texture I just imported. B is going to be what I had. A is going to be the new dirt texture, gravel. So it's essentially looking like this. That replaces what I used to have on base color. And then 2 more steps, I'm almost there. I'm going to add a texture coordinate next to the white texture because I have to force it to run on the different light map UVs. Long story. And I just very quickly have to repeat this over here. Cool. So the point here is that I just want to demonstrate the basic thing of doing something in the material editor. What is it like to work with our material editor? And I've essentially added this third layer with gravel now. Now there's absolutely no difference at all. There's no visual difference. If I compile this and look back here, there's absolutely no difference. But that is because we haven't done any painting. What we're doing here is we're going to use the white texture we just imported as a texture we can modify in the editor itself. So if I switch to the paint tab over here, I can switch to not just colors, which I'll show you in a little bit, but I can switch to textures. And then when you select the model you want to paint on, it automatically shows you the textures that were found within the material assigned to the model. In this case, I'd like to have the white paint texture, because that's the one I want to paint at. So I'm going to paint on that. And then I am going to say UV channel is 1, because it matches the number I just set in the material editor. And then I want to paint with black. And if I paint with black, I can now paint gravel. Hooray. Again, you could have done this with the landscape editor. It's just more about the experiment. Can we do this in a different way, and what kind of tools do we have available in the editor to do this? Build a basic road. I'll leave it there. It's not going to be super pretty. I'm doing this fast, but you get the point. You could have made a nicer road with this. And I can close that. Now, it's a little bit barren, so we want trees, right? We have a built-in foliage tool here. There's actually 3 different ways you can do foliage in Unreal. This is one of the 3. This is also the most user-friendly one. It's painting the foliage. And if I can find back where I put it. I have a couple of different, 2 trees, what is it? Grass, dead leaves, I think, and some other shrubbery. Just drag that in. I'm ready there. Paint, I get trees. Cool. Okay. Obviously, I'm preparing this stuff. I know what I'm doing and have the content prepared, but that's kind of the point. If you're working in production and you have the content prepared, you can do this at the same speed that I'm doing this right here. You can also prepare these assets, and you can also build level content just as fast. Because all I did is just, these things here are actually not the models themselves. These things are specially saved foliage assets which contain the model, because that's the model. But the foliage asset contains some additional presets. You don't need that. You could have actually just directly dragged the model into the foliage tool and paint the model, but then you have to go set all the settings. I didn't want to do that. So I saved the settings. And that's what I mean with Unreal. we've had so much time to redefine the tools. Already in the 1990s, when I started working with Unreal, the tools were crazy. We had a procedural texture generator in 1998 for crying out loud. Okay, that was just cool. It's always been the very heart of Unreal, tools. And it's the same here. Rather than just allowing people to drag a model into the foliage panel, which would have worked just fine, it doesn't work. It's not user-friendly enough. It doesn't work for workflow. It doesn't scale to larger teams. So we start extending it with all kinds of additional things like this. What is it officially? It's called foliage asset, I think. Foliage type. And it speeds up the work. Either way, I'm going to have to paint this a little bit now and take a minute for having to go through. And again, I'm doing this rougher than you probably should do if you're really building something you want to release, but I'm doing this live, so I'm trying to cut some corners here and be a little bit imprecise in the work that I do. Let me set a camera bookmark as well. That's a camera bookmark. Paint some more there. Then I have this. Now it's a little bit empty behind there, still behind the front row of trees, so I am going to say, I don't know, try to reduce the density of the trees. That works. And then just paint with a lower density. I paint some additional trees surrounding the front layer. And again, it's not perfect, but it's working enough, right? So we have trees. And the thing is also, you can still select those foliage meshes one by one. You can see this is growing on the pavement. In fact, if I go outside the foliage tool and I just click it, you can see I can't really move it anymore because the whole thing is treated as one giant object. It's instance rendered, so it's going to render really fast, which is great, but it does mean I can't modify that easily. But within the foliage tool itself, let's go back here, I am still able to select each and every one of them with a tool there, and then I can actually move just that one and just that one. And you know, again, this does take a little bit of time, so I'm just going to leave it be. And I'm sure you can live with grass appearing on sidewalks. Good? Everyone good so far? Good. So we have that. What we don't have, I guess, is a sky. So let's do that next. I have a model here. I'm going to reset the model to 000 again. The model is a little bit small, so I'm going to make it scale 50,000. Now it's a little bit big. Now we put material on top. Cool, I have sky. Then I want the sun on one side, so we rotate that because the sun is going to have to match roughly somewhere there. Okay. So we're getting there. So now we have this. There is no light, so that's the next problem. Normally, what you would do is you would place lights, so you can go to the lights section over there in the placement tool, and you can say, look, I want to have a directional light, which is the sunlight. You know, you can rotate that so it matches the angle of the sun roughly there, etc., etc. You can change the colors and say it should be much brighter or it should be some different tint. It takes a lot of time, so I'm going to delete this in a second and replace it with a ready-made one. But the idea is the same. You would place it, and we simply tweak the settings here a little bit to be something more, appropriate. We're going to do this fully real time. You can see actually the shadow right now says preview. This is a preview shadow, as it implies. This is going to be baked later on. Now, because the baking takes a bit of time, it doesn't take a huge amount of time. It would take about 10 minutes or so in this level on the laptop, but that's still too long. So I'm going to do this with 100% dynamic lighting. The whole thing will be done just with dynamic lighting. We also have the Skylight, and the Skylight is related. The Skylight captures a cube map of distant geometry, usually meaning the sky itself. So essentially, we get a cube map of all of this. And then it uses the cube map to project lighting back onto the level. So it's essentially the atmospheric scattering of light, where light is coming from all directions because the atmosphere surrounding the planet is scattering the light. It's doing that, but it's respecting the color of the sky. If you have a sunset where the sky is orange on one side, blue on the other side, you get blue ambient light coming here, orange ambient light coming from there, because it actually projects the cube map onto the level as lighting. And it's incredibly precise. So one of us tried to do, just for fun, because you would never do this in a game, we tried to simulate a pinpoint camera from like the 19th century, and it managed to do that. The whole thing. It even projected the original image back onto the inside of the box, flipped upside down, as you would expect in the real world. That's how cool it is. The practical outcome of this is that it kind of washes out the lighting in a good way. I mean, we get some ambient lighting here, as you can see. It's not so pitch black, so that's great. And again, we'd have to change the settings. But once more, it's going to take me time, so let's delete that. Let's go to Blueprint. I have something prepared, if I can remember where it is. Drag that in, and hooray, we have light and everything else, including some light bloom-ish. If you look in the building there, it's kind of bright, lighting up there, some kind of bloomy effect. It's just settings in the two things I've just shown, and there is a bit of distance fog, which I didn't previously show. So now I have this. Cool. You can see how easy it is. And again, of course, I prepared this blueprint, but you can make a blueprint like that too for your game, and you know, create content just as fast. I have a few small problems before I can start on the cinematic. One of the problems is that the road is maybe a little bit shiny, and the other problem is that the sidewalks, this might be hard to see for you, but there's a couple of really strange triangles in the sidewalks, and both problems are the same. The way that the shininess is done on the road is we're doing a special material setup using the vertex colors. So if I bring up this material of the road, you can see there's a bit of a larger setup. It has vertex color in here, and that's controlling the reflectiveness of the surface. So if I would paint this with a better vertex color, I can control just how reflective it is, and this is too much. So what I'm going to do now is I'm going to select all the different pieces of road. So now I have the entire road selected, as you can see. I'm going to go back to that paint tab, but not use textures, but it says use colors. And now I could paint. It's not actually, it should be painted yellowish for some bizarre reason. But you can see if you would paint it yellow, you can unpaint the reflectiveness, but not on a texture, but painting directly to the vertex color of the mesh. I'm just going to fill the entire floor with that color, so all the reflectiveness is gone. And then I'm going to paint white instead. And what we get then is you can essentially paint puddles of water. That's the outcome we're after, see. And once more, this is prepared, but if you have a game, you can do the exact same stuff. You can prepare this content and build just as easily. Okay, so now we have that. This one long pool of water is a bit strange there, but ignore that. Now the sidewalk is very much so related. What's actually happening with the sidewalk is I made a kind of merged mesh. It used to be separate meshes. When I merged those separate meshes in one big model, it kind of corrupted the vertex colors. And that's the artifact you're seeing there. Because if I switch this to only display vertex colors, you can see, it might be hard to see on the projector, but you can see the triangles going wrong here due to the vertex colors having been corrupted. So what I will do is the same thing. I will just fill the entire thing with this yellowish color. That's it. Turn it off again. Sorry. And you can see the triangles are gone, and then of course I could start painting some white again. And you can get puddles there too, but it takes time, so I'll leave it be. Good. So now we have this. I need a bottle of water once we get to this point. Any questions so far or comments? Is good? Yeah. Anything? No? Good. So next up, we're going to start on the cinematic itself. I am going to save this first, though, just to make sure. We're going to do the cinematic, and actually I have slides, so I did that. I'm terrible with slides, I told you. I did this except the two middle ones, but I didn't do that intentionally. I did that. I did that. Actually, we're here. So we're going to start with the cinematic. We need the two characters first, then we're going to embed the gun, the rocket, although I might skip that one, and some explosions and hit particles. In fact, some of those particles I'm just going to copy in. The other ones I'm going to place by hand. So here's a few of the particles, and I'll place the rest by hand. Or actually, sorry, that probably was a bad idea. I'll do that later. Characters first. We have two models here I brought in from Robo Recall. One of them is the small robot. Actually, let's start with the big robot. So here's the big one. It's this thing. You can switch to the animation mode and see the different animations. Yeah, sorry, that has sound included, so I'll bring that down some. You can see this is the animation editor. In fact, this is the skeleton viewer and editor. This is the mesh viewer itself. This is the animation tool, and then you have a physics tab as well. So it's all the different tools you might need for characters. Right now we're in animations. You can have animation notifies embedded. So you can see that thing there, the little purple thing, that's the sound that got embedded with the animation. So every time the animation plays, the sound plays as well. The same thing when goes for, where is the explosion? You saw the explosion you saw earlier on. You can include particles as well, it's essentially this one. Sounds and particles, so again, you can really add some additional content to it. Anyway, like that. This is going to be, I think that one. I have note actors, which is just placeholder, but they are there so I can remember where to place the enemies. So that's that one. And then the smaller bot is going to be somewhere. Here is another note actor. In fact, I can just for fun. This is the physics view. This is how you would do a ragdoll. In this case, the ragdoll is actually generated, and it doesn't generate particularly well. So if you do this here, you get that. Okay. You would set this up correctly, you'd be fine. But just for fun for a second. So here's the small robot. Now he needs a gun. And I had a weapon in here. I'm going to drag that in. So there's the gun. I want to have it attached to the hand. So in order to attach this to the hand, I am going to right-click this and say attach to. Now I can find the enemy or the main bot here, and if I do that, I'm going to get a whole list of different bones and sockets. And if you go back to the mesh here, and you go in fact to the skeleton, what we're doing here is you can see a preview gun here. That's just a preview gun. But what we're doing is we're adding sockets. So on every bone in the skeleton, you can right-click and you can add a socket to it. So essentially, you define that bone to be something that something can be attached to. So we've defined a socket for left hand socket, I think it stands for. Sorry, grab socket. So I'm going to copy the name grab socket here. Go back there, right-click this. Attached to, what was it, mainbot 1, I get the list of this, copy paste in the name, attached there, and it's stuck to the hand in the right position, and it'll move along. So that's done too. And then actually I am going to copy paste in the particles. And lastly, over here we need a couple of particles as well. This should be one explosion, that should be another explosion, and I think that should be the big explosion in the middle. So it is boss explode, let's do this. It's a bit big. I am going to say here in the properties of that, do not auto-activate, because it shouldn't explode by itself. And then likewise here, I am going to take, I think that one there, and that one there. Both of those are going to also not start by themselves. And we're here. Good. Then, sequencer, finally. Right-click, new animation, new level sequence. And sequencer is the animation tool that we added for anything to do with cinematics. So cameras, maybe animating lights, animating doors, anything that's not a skeletal animation. Okay, so it's different from the animation things that I brought up earlier, because that's for skeletal deformation and character essentially, but this is for everything else. We had Matinee before, since around 2006-ish as well, and then about a year and a half, 2 years ago, depends how you want to count, we replaced that with sequencer. For us moving forward with the engine, one of the areas where we really want to expand and where we really feel we can explore a lot of new ground is the movie industry and the film industry, VFX industries, those kind of things. And not just for them, of course, also for the game developers, but we've started working on this completely new cinematic tool to really reach out to that audience and really empower people to do more with anything that has to do with cinematics or related animation work in Unreal. And that's what you see over here. It's sequencer. Now, again, this takes a lot of time to set up because there is so much fine-tuning and tweaking and polishing. So what I will do is I will add the things to it in a rough way. enough to show you how you would do it, but it's going to look ugly because I don't have the time to tweak it, okay? Then I'm going to eventually delete that. I'm going to take the ready-made one and continue from there, yeah? So I will start with the small bot over here. We need that one to be present in sequencer. So I have it selected in the viewport, then I can do actor to sequencer, and it automatically takes a selection. So that is my selection. So add main bot 1, and this is now present within sequencer. Actually, sorry, before I do that, let me expand the total length of the animation to, I think, somewhere there. Now it has 2 tracks by default, transform and animation. Let's start with, say, animation. So we can add an animation to it. This shows you all the animations available for the skeleton. I think I need sprint forward first. And then try to find it back. Hold on, it's a little bit off screen. Over there. So you can see here's the animation. In fact, if you play it, he is playing it there as well. You can also just drag on animation, so you can just do this and it will automatically loop the animation. So you can just re-lengthen it as well. In fact, you can also blend animations. So for example, if here at the end I add a sprint forward stop, I think. Let's see, where is it? Sprint forward stop. I'll maximize this. You can drag it underneath, for example, overlap it a little bit. And then if you zoom in, it's maybe too much overlap. And you quite carefully take the top right corner. You can fade out that one and fade in this one, and it will blend the animation work. Zoom out a bit so you can see here he's running, and then he comes to a stop and he aims a gun. So that's what we have now. He's obviously not really moving from all of his running, so that's rather strange. I'm going to do this in a rough way by just manually keyframing the positions. Which means that in the beginning here of the time at 0, that is a position. That's the current position. So I add a key to it, this little button there. You can see that takes that little point over there. That is now the position he remembered. And then I'm going to say, you know, roughly around, say, somewhere there. You should be moving, say, roughly to that position. We press the add key again. And you can see the line appears, and he has remembered the 2 points, and he will just interpolate between the first one and the right one. So, you know, he's sliding a bit. It's a bit fast, but you get the idea. And this is how you would continue, and again, this would take time. Now, what I'm doing here is I'm using different animations that were meant for the game. These are looping game animations, and I'm just Frankenstein copy-pasting, duct-taping all of it together to get a cinematic at the end, because I just took the assets I found in a game. There would be a different way of working than that, would be to animate the entire thing in Max or Maya or something like that, and then bring in the ready-made entire animation for that particular cutscene as one long animation. And that's what we will do for the big robot instead. So I add that one to sequencer as well. That should get an animation too. Let's put the time back in the beginning. Animation, intro tunnel. And you can see the intro tunnel is essentially one long animation that does all of this. So that's another way of working. That's probably, if you're going to do a lot of cutscene, that's obviously probably the better way to go than all the manual tweaking that I'm doing. But sometimes the manual tweaking isn't bad. Sometimes maybe you want to prototype a cutscene, or you know, it's maybe a lesser important moment. I don't know, something that happens in a distance, anything like that. So this animation, what he does is he wakes up, he goes up, he's like intimidating move, like blah, and then for some reason he flies back, and then he comes back again. He makes a loop in the air. It's a bit fast, and then eventually he settles in the middle in front. And then what I would do is I would still add these looping game animations again, just to blend it back to regular, different kind of flying and idle animations. There's other things you can do too. Cameras, for example, would be rather important, I would say, for a cinematic. So in order to create a camera, let's see where we should start. We probably should start near the small robot. I can't remember where I put it. So you place the camera where you want to have it. Then you press this button, create a new camera from the current view, and set it as camera cut. That automatically gives me a camera cuts view track and a cine camera actor. This is the camera itself. The camera cuts track is controlling which camera is active if I have many different cameras. Okay. I get automatically both of them because it's the first camera I have added. And then you want to animate the camera. So essentially it works in the same way. There's a transform track on the cine camera actor. I'm going to add a key in the beginning where we started here. Then I'm going to move the time. Zoom in a bit. Move the time to a certain point. Actually, sorry, that was not on 0. Move my camera. And where I have the camera where I want to have it, I press key again. And what I have now is a basic animation, as you can see. And that's how I would continue. We move the time. We move the camera. We press the button add key. You move the time. You move the camera. You press the button add key. And what we have now is this. Sometimes the rotation, you have to fix that. He thinks that the fastest way between this angle and that angle is 360 degrees in the other direction. It's one small thing that happened here, I think. But either way, that's kind of the workflow. You see, it does that extra turn there. If you want to fix those kind of extra turns, by the way, you can unlock the camera from the viewport, like so. And see, here is the camera. So I can look at the camera itself as it's flying around and try to figure out, okay, so why does it do that? So we can see, and you can see there is a turn as well. He's going to do a turn right there. Tells at the end. Either way, that's the cameras. And I can continue like that. I can, for example, change the focus and some other settings. But again, it takes a bit of time. So what I will do instead is I am going to delete all of this again. And this is where it gets fun. I can right-click this, import to, take a standard FBX file that we exported from, in this case, Studio Max. Could have used Maya too. Then it says, do you want to do that? Yeah, let's do that. This takes a minute without feedback that it's doing it. So it's doing something. So what you could do is you can do the entire animation in Max or Maya and export all of it, including the camera work, including the character animations, the whole thing. Export it directly to Unreal. In fact, what we want to do in the future is, because we're trying to move more and more into the film industry, VFX industries, other industries in general, we can't expect that those other industries will treat Unreal as the end product. You as game developer, you typically use the engine as end product, because I mean the engine becomes the game, right? It is the end. So all of your assets will eventually end up in the game engine, therefore in your game, end of story, game is done. But for all other lines of work, that's not the case. They would use an engine like Unreal as something in a pipeline. So something goes in, Unreal does something, and something comes out again. So we are really, really investing a lot of effort and focus in making sure that you can import things easily in Unreal and also export them again. You can go back and forth between 3D packages, for example, and Unreal. And this is one example of that. You can see now we have the entire camera animation that I set up earlier, including, looking around, zooming in on the robot there. Then he runs forward. Then he follows the loop around to the top, like so, etc. It's slightly off sync. Some other work, etc., etc., etc. So we have the entire animation imported from Max. Right, let's see where we are. We did that. We have done that. There's a couple of small things. Let's talk about these various smaller things. In fact, the material animation might be really intriguing. Small things first. Obviously, you can add an audio track to it. Speaks for itself. It works pretty straightforward. You add an audio track. At this point in time, you add a particular piece of audio. For example, this siren. It shows up there. You can blend the audio in and out. You can add multiple tracks and just slide them back and forth. As you can see, speaks for itself. You can do other things like a play rate track, which is the speed of the playback. So you can add a play rate track, and again, you can keyframe a particular number. So you can see, say, over here it's play rate 1, so 1 times the speed. But over here it's going to go into slow motion, and it's going to go to 0.25, etc. You'll see this come back at the very end. For now, I will just move on. What else do we have? A fade track, it's just fade in, fade out. Level visibility track is rather specific. Material parameter collection, I'll get back to in a second. And I think that's all of the ones to mention. Shot track we'll get back to later on as well. An event track is allowing you to add an event that can then be intercepted by blueprint scripting. And we might have some time for that at the end as well. But these are some of the additional tracks. Now there's one particular thing I want to do that's a bit more special. I want to change the material. My camera is captured. I want to change the material on this robot, because in the beginning the robot is just hanging there. Essentially what I want is that the big robot is cloaked, it's invisible, then it uncloaks itself, it does like rah, and then it flies away, does a loop, and then starts attacking you. So it has to be cloaked. In order to cloak this, there has been something done to the material. So I'm going to bring in the material. You can see it has 3 different materials for the 3 different parts of the model. Doesn't really matter which material I take. You can see this is the whole material setup here. They all look different, but the important part is I added this and each and every one of the materials. And this is a material function. It's just a little node. So it's a custom-made node. If you double-click it, you see it does that. What I did here in the material is 2 different things. You can see it's 2 different outputs using the same information over here. Part 1 is that it takes this texture over here. I'm going to preview that, which is this kind of grid-like texture, and it's just scrolling by, but it's projected, it's planar mapped in the engine. So you can see it planar maps itself in that direction. As you can see, plane this direction, that therefore stretches out. We're going to color that red, so that's the color red there, and we're going to use time and sign to create a basic animation. In fact, I can show you that too. See, that basic on-off animation together with the color results in that. It's kind of gritty pattern. And then up here we do something similar. We have just a noisy texture. But if we bump up the noisy texture with enough strength, if you multiply it with a very big number, we eventually see almost no more black. It just becomes almost white. There's a small section here where it probably should have been white, and it's not white. But still. Now both of these things are controlled by this single number here, which is a parameter. And that number, if you can see, if I would bring this to 0.1 or so, it would make it look like this. So as this number is dropping, you'd get more and more black until it's eventually gone. If it's black, it's invisible. So that number controls that part there, but it also controls the grid effect here. Or it should be, if I can see what I... There we are. Because if it's 1, the grid is gone. If it's 0, the grid is visible. See? So what we want to do essentially, this is the point, this is linked in the material, and we want to animate the value that is found within this function. We want to animate this thing all the way in sequencer. So we want to animate a material in sequencer. That's the real outcome of what we want to do. This is called opacity as a name. I'll close that. I'm going to go back to sequencer. I go back to the track with the enemy bot. And then I need to add a track that does that. Now I can't really add that track very easily, because I mean neither of those 2 are what I need. So I'm going to press add a track. And then my next problem is nothing here says please animate the material. So this is still not useful. So instead what I need to do is I need to add the component that makes up the model. So I add that first. And then on that component I add, you can see now it says materials elements 0, 1 and 2. Now I would technically have to add all 3 of them. I think I'm going to add just 2 of them for the sake of time. I think the last 2 are more important. Both of these need to have a parameter. This automatically recognizes all the parameters found within the material used there. We're looking for opacity somewhere. So opacity, and I'll do this again. Opacity. And then I'm going to see what I will do. Expose the number. You can see it's set to 1, 1. So let's say it starts at 1, 1, but then it goes to, actually, sorry, let's do it the other way around. It starts at 0, and this one too, and then it blends to 1. And you can see what happens there. Is you get this kind of uncloaky effect. Let me extend this, the length of the effect. So you can see that's the third material that we didn't do, right? So ignore that one. Just focus on the other two that we did do. If the time passes, then he starts to undissolve. And do that. And it's planar mapped, so he stretches out at the side. You have a simple little uncloak effect. We essentially just animated the material directly in Sequencer doing this. It shows you how well and how well connected all the different tools are. And again, what I said earlier on in the very beginning, what I like about Unreal is how visual it is and how we have so many different tools, and the tools are the very focus of the engine almost. This shows you that everything works with everything. Everything is neatly integrated with everything. It makes for a very pleasant work experience. Right, let's see, where was I? We did most of that. We didn't do triggering particles, but I'm moving forward. And visibility needed, but it's very simple, straightforward. Visibility means make a mesh hidden or not hidden, so nothing too special there. I want to show you also how you can record physics and other things, not just physics. Imagine you have a zombie game and there's like 50 or so zombies running in a cinematic. Yes, you have a question?
The play rate track, does it also work with animations or only audio? Or the bullet time thing?
The entire thing, yes. The entire cinematic, so whatever is in the cinematic will get speed up. You will see this in the very end. When I show you the final one, I have a slow motion shot where the whole thing explodes and then it gets slow motion and the character's running away with this giant explosion in the background. So that is the play rate track causing the slow motion. Now imagine you have a zombie game. You have 50 or whatever zombies running in a cinematic. You want to have a cinematic with 50 zombies, okay? What you probably don't want to do is go into 3D Studio Max, Maya, whatever you use, Blender, and animate 50 zombies, right? Probably not fun. What you could do is you could just spawn the zombies and run them as AI. So you force the AI to go from this point to that point, and therefore you make a horde of zombies running by in a cutscene or something. But that requires a cinematic to have some form of AI and game logic and all the stuff ticking in the background to add to that. That's probably still not great, right? Plus it adds performance consideration, etc. So what we can do is we can record whatever happens in the game to a cinematic. So we could have recorded those 50 zombies, and it will convert the 50 AI zombies running around to 50 recorded skeletal mesh animations. In the same way, we can do this for physics. So what I want to do here, and it's been a while since I set this up. It's pretty straightforward to do. It's just I might miss a setting. So just disclaimer, I might forget a setting somewhere. I want to add, I think it's that one. I'm looking for a police car. I forget where the police car is. Just try. You can see, by the way, also the material here. It's the same thing. We do some cool stuff in the materials. The car just randomizes color depending on position. Since you have so many tools and so much stuff available, it's easy to just quickly add these kind of effects. It doesn't take any effort. I don't think this is the right one, so I'm going to see if I can change it to that one. I think that looks more correct. And then normally it would be a police car, so you add these lights on top and you touch it. But I won't do that for the sake of time. But imagine it's a really cool police car. Okay, good. I want 3 of them, or maybe 2 of them would be good enough. I'll place one over here. And I'll place another one on the other side of the street. Actually, I have to rotate that so it looks a little bit more natural. Then the explosion is going to happen here. At the very end, we have a very big explosion there, right? That explosion should happen, and these cars should get pushed away by the force. Animating that by hand, not pleasant. It's not going to look natural. We can't make the feeling of gravity natural by animating by hand. So we want to actually do it with physics, and then record to an animation. I set both of the cars to movable. Let's lift this up a little bit. Movable means they're dynamic meshes that will be moving during experience. I enable physics on both of them. Let's save this too. And in fact, if I play this now, they have physics, they fall down. Cars have physics. Let's move this down a little bit again. And then we need the actual force itself. So I'm going to open the level blueprint. And then I forgot my own setup, so add radial force. So I add a custom event. And I'll call it bake, because we're going to bake the animations. So custom event bake, add radial force. Was it? Let me double check what I have. Add radial force, but it might need a static mesh first, so it probably is that. So I get the 2 cars in here. I have 2 cars selected. Also, then again, we change that. Let's do this one by one. So I'll do a small amount of scripting. So I took the 2 cars. These are references to the 2 cars in the level. Now, the physics have to be applied on the model component within the car. So I first have to get the static mesh component. I can't type. Actually, I just take a random one, then delete that. There we are. Fine. Instead of finding the right one. I need that little thing. I need to get the model out of the object that holds the model. I need to have this again for the other one as well. There, and then on both of these, I will add a radial force. And it is both. It gets done there too. And then settings-wise, I had 5,000. I think that's 200,000 there. Try that. And it needs the origin as well, 5,200. And acceleration change, that one. And it needs the origin. The origin is going to be the explosion, because that's the origin. Brought in here as well. Get actor location. And that's the origin for the force. So essentially, if I now run this event, the car should fly away. Let's try that. I can force the event to run if I do CE from custom event in the console log and do this, and you can see now we have that. So that kind of works, and I could probably do this again. Doesn't always move in the most realistic way, but still, we have flying cars. Cool. But every time you would run this, the physics would behave differently. Plus, it takes performance, and they would behave differently. It's not very good for a cinematic. We really want to know exactly where the cars are going to go, so we're going to bake this. There is a sequence recording tool here. Sequence recorder. Now we're going to have to say it should be 2 different cars that we need to add, so I'm going to add this one to it. And then I'm going to add this thing to it as well. So I have 2 references to the 2 things we want to record. There are actually settings in here that it automatically detects anything else that's nearby and records that too. So it's really nice and powerful. You can even record some audio, which is crazy. And then while that window is open, I'm going to play this again. I'm going to press record here, and as it's counting down, we're running the same event again once the countdown is done. Slightly over the top. We wait a few seconds until everything settles. And then we press stop there, and we press stop at the top. And what it made now is it made this sequence asset for me automatically, and this is the sequence asset it made. It made a folder there. If you expand the folder, you see the 2 cars were added to it, and all of the keyframes, one by one, were added to it as well. You can even see it in the curve editor too. See, this is the entire animation recorded to sequencer. A little bit hard to tweak because there's so many points. But as you can see here, the car is duplicated, by the way. That is a feature that's intentional, so ignore that for now. You can see it does this. So you have an animation of the physics, yeah? The playback speed, you mean?
Yeah, you mean how many keyframes it records per...
Oh, I haven't looked into that. It might be in some of the settings here, but I haven't actually looked into that. Because it does record a lot of them. There is a setting called reduce keys, but didn't do a lot, I think. So it might be possible, but I haven't really looked into that, so I'm not sure. No, I don't immediately see that now. But since we now have this as a separate animation, and it's a separate file there, we would like to merge that together with what we did earlier. And what we did earlier was, I can't remember where I put it, this over here. And then I can remember where I put. I have an artist background, my names tend to be bad. And folder structures and everything related to that. So we want to merge these 2 together. And that's the next part about sequencer that's really nice. If you want to make a cinematic, it wouldn't really work to do everything in one view like I'm doing so far. That doesn't work. If you're a big team, it doesn't work. You can't have one giant cinematic and then only have one person working that at the same time, because that's a binary file. the way it's saved. So what you can do for the sake of workflow and collaboration is you can break it up in different sequencer or different shots. There's a couple of different approaches, but they all come down to the same point. And that's what we're going to do here. We have a completely different cinematic, essentially, or animation. Over here, we want to merge the two together. So I can add, for example, a sub-scenes track. And in the sub-scenes track, which is over there, I can add a sequence and then select another sequencer animation. And I think it's probably that one. And you can see this block represents the animation, the cars I just recorded, see? So now I have the animation in one. I have the robot flying there and the animation of the cars in the exact same cinematic. In fact, I could go as far as replacing everything I've done so far with ready-made ones in the same way. I'm not going to do that all the way because I don't need that right now. But you can see here, for example, I have an audio sequencer track which looks like this. This is all the audio we need for the entire cinematic in one particular sequencer track. It's like a layer, and then we merge that entire layer into the main sequencer animation. So now I can go to, close the window again, to the main one here. Again, go to subscenes, add the audio subscenes track. I can just drag it underneath, and you can see here's the entire thing, the entire set of audio. If I double click this, it shows me this. You can see here too, I'm one level deep. So it gets broken up between different files. It's really good for collaboration. You know, another way of doing that, which I won't demonstrate, I just want to quickly bring it up, is the shots track, which essentially is the same thing. The shots track, which use different sequencer assets for every single shot, essentially for every single camera angle or every single camera take. That's a separate file, and it stitches all of them together. Same reason, same benefit. And you can also do different takes in the same way. In fact, I think I can very quickly just somewhere. I rarely do the different takes. I forgot where the takes are on this. But you can do a different take. And different take essentially means that you do a different version of a camera shot. And you can easily switch between the different takes. So you can say, should the camera angle be from the left side of the room or from the back of the room? So it's different camera angles for the same scene. And you can switch between them. So all of that is built in, and that works similar to what I just shown. Good. Good. Everyone good? Are you able to follow? Yeah? Not too fast? Good. Okay. What I built so far is not very pretty. I know that. It's a giant mess. We're almost there to the point where I'm going to delete everything, and I'll just open the ready-made one, which uses the exact same knowledge, but just in a polished way. One last thing I want to do by hand, or at least partially by hand, is this really nice slow motion effect. It doesn't really have anything directly to do with cinematics, a little bit, but I think it's a really nice part of the editor. It's fun to play around with. Essentially, when the small robot is going to shoot the big robot, we want to have this slow motion effect where it zooms in, pulls out the gun, and then it says like bang, and then the robot gets shot and falls down. But that should be slow motion. But it shouldn't just be slow motion. There should be some kind of visual effect that gives you the idea of, cool, something happened, slow motion, right? So I'm going to try to create an effect like that. That's the material you see over here. I'm probably not going to do the whole thing, but I just want to demonstrate the idea. Then I'll switch to showing you the ready-made one and how that works. And then also, once we've done that, we need to get sequencer to animate a post-processing effect as well. The first thing we need is we need to have a material. We're going to affect and change the post-processing using the regular material editor. I mistyped Prague, but I'll leave that be. New material, nothing's going on. I'm going to configure this material to be a post-process material, so it can be injected into the post-processing chain, and we can modify the way the screen is rendered using the material editor. That only leaves me with emissive. That's fine. In fact, I can take the scene texture out of it. The scene texture is what is rendered in the deferred renderer, so the different render passes are now available within the material editor. I will take post-process input 0, which is actually the finished image. Name is a little bit confusing, I think. And then just to make this compatible, I'm going to strip out alpha. So this simply strips out alpha, and that's it. Let's try this first. The most basic thing you can do. I don't think I added that yet. That's good. See here. I will add a post-process volume. Move it a little bit in the middle. In Unity, I think you have to enable, I don't use Unity often, but I think you have to enable the post-process settings you want to use, I think. In Unreal, it's in any case the other way around. So everything, almost everything, is enabled by default. And you have to turn off the post-processing or modify the settings that you want to modify. If I add a post-process volume to the environment, like I did now, that's that little frame there that might be hard to see, but there's a little box there. That little box has a lot of settings in here, which controls everything to do with post-processing. So for example, I could say there should be a lot of bloom. I have typed 500,000. This is going to look bad. Now, this doesn't affect it unless I'm inside the box. It's a little bit bright, maybe. Let's actually try a smaller number. Actually, that's still very bright. See, okay, like this. Cool, next gen. There's also a setting here that says unbound. Now it affects the entire world, no matter if I'm in the box or not. And so on and so on. But that's the thing, see? It's not because I enable the box that I enable bloom. In Unreal, almost all of it, there are exceptions, almost all of it is enabled by default. Ticking the box just enables the override, not the effect itself. So now I set the override to, okay, let's actually do like this. Still blooming, but whatever. But as part of this, there is also a section called Rendering Features, Post-Processing Materials Array, adding one input to the array. That's an asset reference, and that asset reference will be the material we just made, hooked it up, and what we did now is we have this material in the post-processing chain. Now you can't see anything happening because I haven't actually done anything. I simply took the screen as is and input the screen as is. I didn't do anything. But the moment I start doing anything in the material now, for example, I don't know, we multiply it by red. And I prove that. It's red. So whatever I do in the material editor will now be passed on to the screen. And that gives you a lot of possibility. Because, for example, one of the things that we want to do is we want to distort this texture with some kind of line pattern. Or let's see if I can find back where I put the grid. Oh, grid. Cool. Grid. So this is the same grid texture that we use for the robot. It's just a grid. I could do this. You take the UV coordinates as is, so the screen coordinates as they are, but you add an offset to them. So this adds the offset. I'll take the red color only. That gets put in over there, and that's a little bit extreme. In fact, I can show you that right away. It's so extreme you essentially really see the lines, but it's distorting it. But it's, again, so extremely over the top that you don't notice. And I'm actually going to switch not to red. Green is better. So let me take green. So instead of doing it so over the top, I'm going to multiply it with something. And I'm using green as mentioned. I'm going to say this is 0.2. Try that again. This might be hard to see, but it's distorting between the lines. It's a little bit distorting. Let me just, for the sake of making this clear, take a random cloud or noise texture here. See, now you have that. In fact, if you want to make water, and let me remove the color as well, it's a bit easier to see there too. Let's add a panner to it and change this to 0.075 or so. Actually, sorry, I didn't set the speed in the panner. Basic, but you see how easy it is to go to some kind of watery effect if you keep on going like this. It's that easy. What we want to do here is we want to have some kind of lines that pan over the screen. So let's just do this. Now this is the grid. It's not the actual correct texture, but it's good enough for the basic example. Something like that. I'm doing additional things too. I'm creating, I think, my own distance fork. If I remember correctly, I do need to remember the distance of it. So what I can do here is I can take the depth of the environment. For example, scene depth, which I don't see. Scene depth. Again, I take the component mask to strip out alpha. And once I've set this up, I've shown you this basic example, I'll switch to the ready-made one. I'll show you the whole thing in a more proper setup. This takes the depth of the environment. The depth of the environment is a little bit of a big number, so I'm going to scale that down to 0001. I think you can see what I have here, 0.3 times 0. I have 3 times 0. Clamp for security. And then, for example, you can take the red color we had. And I think the setup was like this. Let's try that. Might be the wrong way around, but we'll figure it out. So essentially now I made distance fork just in the material. It's fun to play around with. That's the point. Okay. I'll show you the ready-made one. So delete this. I am going to add the ready-made post-processing. The ready-made post-processing has a setting in there, a material in there, and then this is the material itself. Roughly based on the same idea. All of this is tied down to this one number. That one number is controlling the entire effect. If that number changes, the effect changes as well. So I'm going to blend this one into the cinematic. This is a special case. Because normally what you would do with a material, like we have on the robot, we had to say, take this robot and take this material on that robot and change this setting. We can't do that now because we can't tell the cinematic, use this piece of post-processing, because post-processing just exists. You can't refer to it. So we're going to work around that by using a material parameter collection, which is kind of like a super global parameter. So it's the global parameter that drives it in the material, and it's the global parameter that gets set by the cinematic. And therefore, that's causing the bridge between the two. So in here, that's what I'm going to do. I'm going to add a material parameter collection track. And using, I think that one. If I can remember correctly. I'm going to add a key to that. So here is parameter is called effect. That's the value we have in there. The effect is currently 0. Now the effect is 1, and now the effect is 0 again. And that's blending in the material we just talked about. So it looks like this now. See, it blends in. You get this reddish distorted effect, but only in the distance. It actually desaturates everything, except for models that have been set to the property custom depth. Custom depth. True, it doesn't, oh sorry, wrong type. Custom depth, true, let me show you now. So I've set the big robot to be rendering in custom depth as well. You see, that leaves it colored, even though the rest is desaturated. See? Also, I have a kind of fisheye effect. I'm changing the field of view purely with the material editor. You can go far. Cool? Are there any questions? Because I'm going to change level. Any questions on anything I just did that you want me to play around with, mess with, anything? All good? Okay, then I'm going to take the ready-made level. And show you how it comes together. You can see there's a few extras here. For example, this stuff has been placed with a blueprint. So I made a little blueprint script that changes the number of meshes placed. So again, you can use blueprint for all kinds of different things, not just for gameplay scripting. We also use blueprint here to trigger some smoke in another couple of blueprints, etc., etc. So what else is there? There's a black planes, which are probably the only thing I should really bring up. The two black planes are playing videos. You can see it's two giant black planes. So what I wanted to have is I wanted to have a swarm of robots in the distance, like a giant swarm of robots. But it's rather performance heavy because you don't want to render like 3,000 or 4,000 actual robots flying around. I mean, maybe you could have done that in one way or another, maybe instant skeletal mesh rendering, some kind of crowd system, etc., but let's not go that far. Let's just render it out. That's what I did. Now, my solution is a little bit messed up in a way as well. I did it mostly because it was cool. In real production, I would have done it with a particle system and a flipbook animation of little robots doing flop, flop, flop or so in the distance. You know, I would have done something like that. What I did here is I recorded an actual video, which was way over the top. But it's cool you can do it. So I did this. I made a blueprint of a single robot just playing a looping flying animation. So it's just that. Then I wanted to have hundreds of them. So I made a second blueprint that spawns the first one. See, it's a box. And it says within this box, you're going to spawn child actors. And each of the child actors is one of those other bots. I moved it. And then I add a property to it, which is bots to spawn. And this is how many we get. So now I can have 50 of them, or however many I want. It just randomly generates robots hanging in the air. And in-game, they might be a little bit animated to it. Not sure if I did that or not. I think they're moving as well in-game. They're just going up and down. And then I made a level that had a green background. So the entire level is just green screen, essentially. I placed the robots in front of it. Then I made a sequencer asset. I'll very quickly show you this. At least show you in the UI. And I did this option over here. Where is it? Render this movie to a video sequence. So you can export whatever you do in Unreal to files that, you know, an exportable format. I did that. That in turn rendered this thing here, which for some reason you can't play. Come on. Which is that. So now I have a video of a bunch of robots flying on a green screen. Then I imported the video as an actual texture in Unreal. And then I put the texture in a material, and that results in robots appearing in-game. Way over the top, really cool you can do that. Let's see if we can quickly make sure it's not black there. If I can remember exactly where I put some of this stuff. See, like that. It's a giant hack, but it was a fun little project to try. If you get up close, it is really low resolution, so you can see it's not particularly brilliant. But from far enough, and also it's relatively heavy playback-wise, so again, in real production I would have used a particle, but still, fun to play with. Good. Then I'm going to do is I'm going to play the cinematic, and as it plays, I'm going to show one last thing during playback. The sound might be a little bit simple, I'm not sure. Actually, I have sound of those, okay? The one last thing I want to show you is how you can script a cinematic. Let's say you want to change something in the cinematic as it's running, or before it's running, whatever. Say you have a game where you have multiple players, multiple characters. You don't know exactly which character is actually doing the cinematic. So you want to be able to script the one participating in the cinematic. I only have one robot here, but I'm going to change the robot during playback with, I believe it's this mailbox. So that mailbox will be the one shooting the robots. Okay? But just for the sake of showing you how easy it is to script this, and in fact, all the scripting it will take me to do that is what I did here. And most of this isn't even related. I think the related part is what it's called change. See, if you run the event change, it takes the cinematic itself, which is a reference there. Then it takes a binding within that cinematic, so it takes the binding mainbot1, because we want to change the mainbot, and then it takes the mailbox, adds that to an array, and the array is the one that gets set. That's all. That's all I did. Good. Just need to get the names right. I need to run start mof, and then I need to run change. And that's a bit loud, maybe. Okay. Play Moth, I think it was. Actually, sorry, I got the name wrong. I've got the name in 1 second. I just looked at it. What was the name? Start Moth, yes. There's a flag on a gun. I don't know why I did that. So, mailbox running away in slow motion. The other bot was still frozen as I changed, but still, it works. And then also one very quick last thing that I really want to bring up as well. If you would now say, look, that's really cool, but I want to do something with this elsewhere or in some way export this, I could actually export the entire thing, literally everything you see except the particles and the sounds, to an FBX file, which is, I believe, that entire file, which is 56 megabyte. I can't easily show you that, but if you would then import that in 3D Studio Max, I made a video of that. What you would get is this. So that's how it imports. If I would have had the textures in the right place, it would have even automatically assigned the textures. It takes the animation blending of the different animations. It takes the whole thing. It takes the foliage. Everything is just exported back and forth. That's what I mean. We want a pipeline where you can bring stuff in Unreal, you can bring it out, you can go back and forth as you see fit. And it's really cool. You can just get everything brought over into another application. See, it's the same thing. So that's really fun. Good. We did that, we did that, we did that. Yes.